Alright, here's our 6.5 lesson. This is going to be titled Discounts and Markups. A really cool lesson that kind of shows us how things like coupons would work, or like how a store has to mark up things to sell for a profit. Real world application is huge in this lesson, and actually it's the basis of this that we then get to do our shopping spree project with a whole bunch of discounts and markups coming up next. So in this lesson, our learning target is to be able to solve percent problems involving discounts and markups. Okay, in order to do that, we're going to use percent models to solve problems, including discounts and markups, and then write and solve equations to solve problems involving discounts and markups. All right, so in this lesson, we've got a couple key ideas. First of all, a discount is just a decrease in the original price of an item. So typically, when we hear discount, most people would think of like a coupon, right? You might have seen coupons for like 10% off or 15% off. That means whatever the price is of the original price of the item, we are going to take away 15% of that to get our new sale price. Okay? A markup is just the opposite of that. This is when a store like buys something and then wants to sell it for more so that they can make a profit. That margin of where they take their original price and mark it up is what is known as a markup. What's also nice in this lesson is that we get to kind of go back to our A, P, and W format. Okay, just like in lesson 6.2 and 6.3, where we're working with a part, a whole, and a percent, we can still use the same letters and the exact same proportion or equation, except A and W kind of change a little bit. Okay, this time A is either going to refer to the sale or selling price. Okay, what do I mean by that? It's going to be a sale price when I'm working with a discount, and it's going to be a selling price when I'm working with a markup. Okay, either one, right, as long as I'm looking for a sale or a selling price, that refers to our part, or A. W is going to refer to our original price. Okay, it's where the price started with, whether the store got them for this price or that's originally what it cost before a discount. My P is still going to mean percent, except this time percents are going to kind of change a little bit in how they work. Some methods are going to remain the exact same. There's nothing left to touch. Other methods are going to help us a little bit more, especially when we're missing our original price. Okay? Otherwise, the exact same formats can be used. A over W, P over 100, that will still work. Or for the equation A equals P times W, that will still work as well. So let's jump in. We're going to start with discounts. We're going to see kind of how this all blends together. You should see some familiar things and then some new things that are more specific to this lesson. So for example 1, when we are trying to find a sale price, remember A is going to refer to that sale price, W is going to refer to the original price, and P is going to be my percent of discount. Okay? So there's going to be two different methods we're going to talk about. We're going to do method 1 first, and then we'll look at method 2. So it says the original price of a video game is $35. What is the sale price? So I'm going to go in, just like I did last time, and we're going to label each of these different things with kind of an A, a P, or a W. My original price of a video game is $35. Now please, I know it says is 35, so it's really easy to, oh, that's A. Okay, we have to think of our context here. 35 represents my original price, that is W. Okay, what is the sale price, right? It's asking about A, since I don't know it. P might be a little hard to find, but it's actually right on our picture, right over here. And it says it is 25% off. So that's going to be our P. Okay? Now, whatever method you like, the equation, or if you like the proportion, you can do that. I'm going to use the proportion in these. If you like the equation, you can do that as well. Okay? So first what we're going to do is we're going to find the amount of discount. Okay? And it's going to look a little bit different than you might think. So, I don't know A. That's my selling price. I don't know it yet. I do know that my game cost $35 originally, and it's on sale for 25% off. Okay? Now, before we get too far, I'm going to tell you that when we get our answer where we get like A equals, that is not going to be my selling price, and we'll talk about why. But I still can go through exactly the same as I would normally to figure this out. So I'm going to cross multiply and cross multiply. 35 times 25 is 875, which equals 100A. Dividing by 100 gives us a price of 8.75. Okay? Now let's think about this. 25% off means I'm taking away a quarter of the price. Looking at 35 and thinking about what is a quarter of 35, well, we figured it out, it's 8.75. But that's how much I'm taking away in this context. I'm not actually saying that 875, that's what I get to buy it for, right? That'd be way more than 25% off. Okay? So in a situation where we leave P as the percent off, we actually are going to say that my sale price can be found by taking my original price and subtracting my discount. Okay? So we're going to do 35 minus my amount of discount is 8.75. 35 minus 8.75 will give us a final sale price of $26.25. Okay? So again, if we leave our percent alone, whatever the percent we see, that's what we leave it as, right? This will automatically set us up to get a discount amount where we then have to take that away from the original to then get our sale price. So some people like this, right? Whatever they get for A, they take it away from the original and they get their sale price. For method 2, we're going to think about what does it actually mean to be 25% off. Well, let's think about this. If I paid 100% for something, right? No discounts, nothing at all, I would be paying the original price. So we can almost think of 100% as like the original price. And just like in our last method, we took away a discount amount, right? So our amount of discount, and we eventually got our sale price. Thinking about it in a different way, so with percentages, we truly are only paying 75% of the original amount. Okay, 25% off means that I'm responsible for the rest of the 75. So another way that we can think about this is we can have the exact same setup to begin with, so A over 35, except what we can do is we can say the original percent off minus my discount percent will tell us how much of the original price am I paying. Okay? So when I go through and I do that, I am now paying 75% of the original price. Okay, 25% is covered by the store through the discount. I'm responsible for the other 75. if you go through this, what ends up being nice is that when I cross multiply, I get 2625 equals 100A. And when I divide by 100, we see that I end up at that sale price. So there's kind of two methods. The first method would be find how much discount you've got, subtract that away from the original price, and boom, you've got your sale price. The second method that we just looked at here is thinking about, okay, how much of the original price am I actually paying? In a discount scenario, I'm going to subtract my percent off from 100 to realize that I'm actually only paying 75%. Okay? So there we go. Looking at this in another example, I kind of want to show you just another version of this, looking at those two methods. Okay? So method 1 has us finding an amount of discount and then subtracting that dollar amount away from the original. So it says a portable tennis table, a table tennis set costs $30 before a 30% discount. So originally it cost 30 bucks. I have a 30% discount, so I can apply that towards this price. I don't know my sale price. 30 refers to my my original price. And in method 1, we left the percentage alone. Right? So I got something that looks like this. I'm going to cross multiply here, and I get 900 is equal to 100A, which leaves me with A equaling 9. Now in this method, this is not my sale price. This is how much I need to take away from the original. So going back through, 30 minus 9 gives me a sale price of $21. Which makes sense, right? A 30% discount is less than half off. I shouldn't be at 15, right? 15 would be half off of 30. I need to be a little bit above that since I'm not taking, or I'm taking less than 50% off. Our method 2 said, set up the first part the exact same, except this time, figure out how much of the original are we actually paying, right? 100% would be the original, 30% is my amount of discount. This leaves me paying only 70% of the original price. Cross multiply, 100A is equal to 2,100. Dividing by 100 gives us an A value of $21. Okay. So again, both methods shown out again. One way we subtract at the end. One way we subtract our percents right away. And then I can go through as normal. Alright, here's your try it problem. We have the original price of a skateboard. It's on sale for 20% off. What is the sale price? Please try this out, and we will go through it next. So my original price of a skateboard is 50 bucks. Original price always goes with W. Skateboard is on sale for 20% off. That is P. What is the sale price? I'll show both methods. For method 1, A over 50 is going to be equal to 20 over 100. Cross multiply, 100A is going to be equal to 1,000. And I divide by 100 to get a amount of discount of $10. Knowing that, I'm going to take my original price, subtract by 10, and end up with a sale price of 40 bucks. If you chose method 2, we will still have A over 50. This time I need to subtract my percentages. 100% would be of the original. Take away the 20% off. This means that I am only paying 80% of the original price. Cross multiply, cross multiply. If in this situation you just wanted to look and see if you can make a connection, do I need a cross multiply? No. Cross multiplying always works though. 100A equals 80 times 50, which gives me 4,000. Dividing by 100, we see that our answers match. All right, so that was sale price, right? When something goes down, what is menu price? We also can do the reverse. Well, what happens if I know my sale price and I want to figure out where I started? Okay, so this time we're going to be finding an original price. Now for finding the original price, we really have one option here, and that is to use the method 2. Okay, and the reason for it is I can't find my amount of discount only from knowing my sale price and the percent off. Okay, that's just not going to work. So instead, I need to think about method 2 and try and think about, okay, how much of the original price did I end up paying? Okay, so when it says now 33, that means this is my sale price. This is what I would pay now after a 40% off coupon. Okay, so if I know my original price would have been 100% of the cost, and I applied a 40% discount, or I took away 40% of that price, that means I paid only 60% of the original price. Right? Original price. This is like a discount percentage. I only paid 60%. From here, it actually becomes a really nice way of doing this, as long as I use 60% as my percentage. I'm going to get 33 over W. 60% is how much I paid of the original. And now from here, we can go about this just like we have in the past. 3,300 is equal to 60W. I'm going to divide both sides by 60. And I get an original price of $55. Okay, another example just for you to see again. We've got a discount on a toy robot. It's 40%. The toy robot is on sale for $54. This is my sale price. That's A. I'm missing W. Again, I got to think about it. 100% would be my original price. My discount is 40%, meaning the store is taking away 40% of the cost. How much then am I actually paying? Just like in the last example, I'm paying 60%. So to set this up, A was 54. I don't know how much I cost at the beginning. However, I do know that I paid 60% of the original price. 54 and 60. So we got 60W equals 5,400 or 5,400. When we divide by 60, we get an original price of $90. All right, here's your second try it. This time I'm given the discount percent. It gives me my sale price. I want to know what is the original price of the DVD. Go ahead, try it out. See if you can come up with it. All right, this time my percent off is 50%. It is on sale for 10. A is my sale price, so I'm going to say that's A. I'm missing my original, meaning I need W. Now this one actually works out to be kind of nice for us. If 100% is the original, and I take away 50% of it, right, that's my amount of discount, then the amount that I paid is also 50%, right? This is almost like the store covers half. I just have to cover the other half. Okay? So I know that A is 10. I don't know where I started, but I do know that I'm only paying 50% of the original price. This one works out to be pretty nice. You can go about this a whole bunch of different ways. Our failsafe is cross multiplying. 1000 is equal to 50W. Divide both sides by 50. We should have got an original price of 20 bucks, which kind of makes sense, right? If my sale price was 10 bucks and it was 50% off, well, I had to start at 20 because half of 20 is 10. All right, last example here. We've talked all about this discount, right? So when I take away, how much am I actually at? Okay. For this one now, we're going to be looking at something called a markup. And this is where I said that A has two different definitions. For a markup, we're going to say that A, instead of sale price, is now our selling price. Okay, again, selling goes with markups. W is still the original price. P is still my percent. Except the only change with this one is markups. Anytime we subtracted with discounts, we now are going to add, because I'm adding more to the price. I'm making my price more. So again, we can use both of our methods, and it's kind of going to work the same. Again, the only difference is adding instead of subtracting. So a store pays $70 for a bicycle. That's how much the original cost of the bike was, 70 bucks. The selling price, I don't know, but my markup, I do know, is 20%. That means the store is going to increase the price by 20. Okay, so first step, I'm going to do just like we did before. Okay, A over 70 equals 20 over 100. We're going to cross multiply that through. I get 1,400 is equal to 100A. And I find that the amount that the store has increased the price by is $14. With method 1, I need to use $14. And instead of subtracting it away from my original, I'm going to add it to get an original price, or sorry, a selling price, my bad, of $84. Right? I started at 70, I marked it up 20%. It now is going to cost someone 84. Method 2 kind of looks the same. I'm going to have A over 70, except in discounts we did 100 minus the discount. In a markup, we're going to do 100 plus the markup percentage. So this time it's going to be 100 plus 20%. Okay, we should notice now that my numerator is greater than 100, which makes sense because I want my A value to be higher than where I started. That's what markups do. Cross multiplying this out, 120 times 70 gives us 8,400. 100A divided by 100. We get our matching answer of a new selling price of $84. Okay, here's your last try it. Okay, using that example we just did. Again, we're looking at a store sells a memory card for $25 each. The markup for each memory card is 25%. How much did the store pay? Now, really quickly, okay, we've got to think about our context here. I'm going to kind of help you get a start. A store sells memory cards for $25 each. This selling price means that I'm actually given A, and I'm told that it gets marked up 25%. So this is my P. So just like when we were solving for an original price in discounts, I can only use method 2 here and say that 25 over my original price would have been, right, it's 100% is the original price, and my markup added 25%. Okay, so with my markup, I had to add 25% to get up to this $25 price. Now that you have this set up, you can go ahead and solve for the original price. And then once you know that, I just want to know how much would it cost them then for 50 of these cards. Okay, so with this setup, right, A represents that the store is selling them for a price. That's the marked up price, and it was marked up by 25%. Okay, this simplified is going to give us 25 over W and 125 over 100. We're going to cross multiply to get 125W equals 2,500. Dividing by 125 gives us an original price of 20 bucks. That's initially what they bought all these for. They then marked it up 25%, and then they sold each of them for 25. The store paid 20 per card, so it cost 20 bucks a card, and they bought 50 memory cards. Then that means overall the store had to pay $1,000 for 50 memory cards. All right, that kind of concludes our lesson. Big takeaways from this would be when I'm solving for a selling or sale price, I'm solving for A, I can go through either method, right? Method 1, where I find how much I'm either adding or taking away, and then add it or take it away from the original. Method 2, either add or subtract my percentage to figure out how much am I actually paying of the original. And then I can go ahead and cross multiply and solve for A that way. When I'm trying to find an original price, I must use method 2 and figure out how much of the original did I pay, and then I'm solving for W. All right, we'll continue to work with this more. We do have a project coming up with it, so we should become pretty familiar with all of this. And if you have questions, certainly refer to this video or any of the homework help.